Hello everybody, this is Chris back again with the Ancient Scholar. I want to go ahead and continue along the lines of talking about complex numbers and imaginary numbers, really analogous, but what I want to do now is I want to go ahead and I want to make a true complex number. And I want to show you the power of something known as the complex conjugate and kind of how we can use that to give us a real number, to kind of make sense of imaginary complex numbers. And again, I kind of related this back to an analogous process will occur when we look at the wave function, and we actually take the complex conjugate of the wave function, multiply it by the original wave function, and we get real numbers out of there. While I'm certainly not in any position to actually show you guys that, what I can do is show you an analogous process that involves much simpler numbers to work with, if you will. So let me go ahead and let's just make up a number here. 3 minus 4i. Okay, so this is a complex number. And what we have here, we have two parts to this complex number. Right here I have the real part. This is a real number. This is the real part. It's a real number. And obviously we can visualize that and we understand what it means. And then I have this 4i here, and this is what we call the imaginary complex part. The imaginary part. Now, clearly, it's somewhat difficult to make sense of this number. So, something I can do to kind of make sense of this number and kind of turn it into something that I can work with, it's maybe perhaps more intuitive and it'll give us real numbers, is actually taking the complex conjugate of this number. And the complex conjugate is nothing more than taking the opposite of the imaginary part. And what does that mean? Well, it means this. I will go ahead and just show you the complex conjugate of this number. 3 remains the same, but instead of negative 4i, what I'll do is I'll go plus 4i. I'm going to go ahead and put parentheses in these guys here, because that just lets me know that they're different and that I'm going to be doing some stuff to them. Okay, so now I have these guys, and I'm going to go ahead and multiply them. I'm going to take the product of them. And we have polynomials here, and if you remember from algebra, I think there's something called the FOIL method. I don't really know what that means. I've heard of it, and again, I've never taken Algebra 2 in high school, or probably junior high, I would say. So what I do is I just multiply everything by everything, and I'll show you what I mean. Is I just start over here on the left. I start with 3, and I multiply 3 by these two, and then I work my way over to 4 and do that. So I'll just go ahead and draw the line. So what I'm going to do is I'm going to move over here. I'm going to have 3 multiplied by 3. And what I'll do is I'll put the answer down here. So 3 times 3 is nothing more than 9. And then 3 multiplied by 4i. Well, what's 4 times 3? That's 12. So it's plus 12i. Okay. And then I go ahead and I move over to negative 4i here. Negative 4i times 3 is just negative 12i. And perhaps you can already see something interesting that just occurred. But we'll keep working our way through it. And then I'll go ahead and move over here. Okay, negative 4 times 4 is negative 16, and then I times I is I squared. Okay. Well, I know you guys are probably thinking, well, wait a minute, Chris, wait a minute. Okay, so this is really cool here. I can cancel this out. And I can cancel this out, right? Positive 12i, subtract 12i is nothing more than 0. So that's cool. That's great. And then I just have 9 minus 16i squared down here. Well, that's great, but I still have an I squared. I still have an imaginary component there. I didn't really do much of anything. Well, if you remember back to the I video, what does I mean? I is the square root of -1, right? So if I were to take the square root of -1 and square it, well, what is that going to give me? That's going to give me a real number. That's going to give me -1. So really what I have here is I have 9 minus 16 times, right? And I squared is nothing more than -1. Well, what's -16 times -1? Well, that's 16. So, in fact, what I have here is 9 plus 16. And lo and behold, that gives me a real number. It's really interesting how this works out and how we can use this concept of the complex conjugate to our advantage. I might as well put that number there, huh? All right, there we go. So you can see I started out with 3 minus 4i, and I multiplied it by its complex conjugate. It was nothing more than the opposite of the -4i, or plus 4i here. I got a plus 12i and a -12i. They canceled each other out, and then I ended up with this 9 plus the minus 16i squared, minus 16i, 9 minus 16i squared, but we already recognized that I squared is nothing more than -1, that -1 times a -16, well, negative times negative is a positive, 9 plus 16. So what fell out of this original complex number here is nothing more than this real number here. And then we can usually interpret this real number as something. In the case of the wave function, of course, the wave function is just a bit more complicated than this, but the wave function still contains a real part and an imaginary part. So the operation is very much the same. This is just a bit simpler and a bit easier to do. It's pretty much the same operation, and I end up getting a real number, and obviously I interpret that real number in the case of a wave function as a probability density for finding, in most cases we're talking about electrons, but it could be for finding the location of a system or any number of quantum objects, if you will. And there, of course, are other things that we can do with complex numbers other than just that, but that's just something that comes to my mind. Anyway, guys, I hope you kind of enjoyed this. I hope this gave you some intuition, and anytime you get any complex number, just go ahead and try 5 plus 2i. Take the complex conjugate of that, 5 minus 2i, and work it out, and I guarantee you're going to get a real number falling out of that. Okay, guys, hopefully that makes sense, and thanks for hanging in there. Take care.